Hello, my name is Louis Pritchett. Today I will show you how to determine the truth table for a 74151 multiplexer selector chip and how to wire it. As part of our presentation, I will be using notes from a lecture presented by Professor O'Donoghue of Chattahoochee Technical College. This is the logic diagram of a 74151 8-input data selector. The number of the 74181 is like a single pole 8-throw switch. There are 8 data inputs, and a connection can be made between them and the output through the selector switches or the binary combination of selector switches. Each binary combination of the selector switch will have a corresponding data input. In this example, D0 corresponds to the binary combination for the numeral 0. D1 corresponds to number 1, the binary combination number 1. D2 corresponds to the binary combination of number 2, and so on. This is the pin diagram of the selector chip. This tells us the location of the inputs and outputs in order to wire the circuit. In this example, D0, which is on pin 4, is connected to 5 volts. By connected to 5 volts, the output will be a 1. D1 on pin 3 is connected to ground. By connecting it to ground, the output will be 0. D2 is connected to on pin 2, is connected to a 1 kilohertz square wave with a 5 volt amplitude. This demonstrates that not only can you connect a value of 0 or 1 to a pin, but you can also connect more dynamic data inputs. D3 is connected to a 5 volt source, and again, that gives an output of 1. D4 and 5 are connected to ground, again, outputs of 0. And D6 and D7 are connected to 5 volts. The enable is connected to 0. If the enable is not connected to 0, then what will happen is the output Y will either be a 0 or it will be a value that is not intelligible. By taking the binary combination of selector switches with their corresponding data inputs and the values assigned to each data input, a truth table can be created. So we have the 7 data inputs, binaries numbers 0 through 7. We have the data inputs, D0 through D7, and we have the outputs that have been assigned to each pin or to each data input. And once we have that all together, what we have is a truth table. And the value of the truth table is that if you are looking for these outputs at these different addresses, you can go to each one line by line and check to see that the output corresponds with the address. In order to wire the circuit, again, we refer to the pin diagram. And wiring is pretty straightforward. For instance, pin 16 and is automatically tied to a 5-volt source. Pin 8 is grounded. And then the different data inputs are attached to each one of the data inputs. For instance, again, D1 was attached to a 5-volt source. D2 was attached to attached to ground. So once the inputs are assigned and attached to their various inputs or outputs, then an output will either be Y, or if it's an active low, it'll be this output on pin 6. The selector switches are connected to pins 11, 9, 10, and 11. Once these assignments are made and once everything is wired, the circuit should look something like the one that I did earlier. Again, the wires are either going from the switches to the selector switches, going from ground to the various inputs, data inputs, and enable, and the ground on pin 16, on pin 8 is connected, as well as the 5-volt source to pin 16. Again, in order to prove that this circuit works correctly, you'll have to go through each line of the truth table to determine what the assigned output is. If the assigned output appears, then the circuit is wired correctly. Thank you.